To review once again, an electrical utility is a business, and like any business, it must be paid for its product. And, like any business, it measures the amount of product it sells, electricity, and charges for precisely that amount. The utility uses a meter located at each customer's location to serve as its cash register. And like virtually all older established businesses, utilities are replacing its old-fashioned cash registers, like this one, with a modern meter based on 21st century technology, like this one. Oftentimes, these new meters are referred to as smart meters, and like the old-fashioned power meters, the smart meters measure power traveling through them by measuring natural magnetic fields. The smart meter makes only passive measurements, and unlike the old-fashioned meters, the smart meter introduces no new magnetic fields in the measurementation process. And the modern smart meter has no mechanical or moving parts, which can cause the meter to become inaccurate over time. Most notably, old-fashioned meters use a series of fixed permanent magnets to add drag to the magnetic sensing mechanism. Over time, these magnets gradually lose their field strength, which causes the meter to spin more rapidly, charging the customer for more power than they actually use. Now, let's examine the inner workings of a modern electronic or digital smart meter. Before we leave the subject of an old-fashioned electromechanical meter, as so eloquently described by Mr. Tom Towns of Westinghouse Electric Meter Group in the third part of this Smart Meter series, let's look at a 75-year trail of electromechanical meters. Here is a 75-year-old General Electric Class 100 meter. Notice the 4 dials and the large permanent magnets. Here is a 50-year-old Westinghouse Class 100 meter with 5 dials. This meter ushers in the almost modern era of the early 1950s. And here is a 25-year-old ABB, who, by the way, bought Westinghouse Meter Group a few years ago and then sold it to Roy Gas, who in turn sold it to Elster, who was bought by CVC, who recently announced its intentions to sell the group once again. Yes, the Westinghouse Meter Group has been bought and sold 4 times since I first worked with Mr. Tom Towns in the mid-1980s when I was running Datamatic in Dallas. This meter is known for its cyclometric style or odometer-like dials, which can be read by anyone, including utility customers. Unfortunately, this style was never popular with utility companies. This meter is the last of the modern electromechanical meters and is a Class 200 amp meter. Note the reading of this meter as of this point in our lecture, and notice the spinning disc or stator, as Mr. Towns referred to it, and its rotation. At the end of this lecture, we will revisit the dial indicators. And remember what I said earlier about the internal permanent magnets. Like a horseshoe magnet with its field keeper removed, over time this magnet loses its strength. And as it loses its strength, the meter speeds up. What does this mean? It means the customer gradually pays more for less electricity that he uses. And by the same principle, smart but dishonest customers can take a strong magnet, and by placing that magnet in front of the rotating disc, they can bring this disc to a virtual standstill for, say, 2 weeks out of the month. Why would they want to do that? Because by bringing the disc to a virtual standstill for 2 weeks out of the month, they effectively cut their electrical bill in half, thereby stealing a great deal of the utility's product. Oh, one final magnetic thought. I would be remiss if I did not bring this up. The electrical power traveling through the power meter is AC, meaning that it is alternating current. Thus, all of the magnetic fields in the meter reverse their north and their south poles 120 times per second for a full cycle of 60 times per second, equaling 60 hertz. The magnetic fields are placed in certain phase relationships, which cause the magnetic stator, or spinning disk, to rotate in a counterclockwise fashion, or left to right, as Tom Towns taught us in part 3 of the series, and as we see here as a function of the black mark on the disk traveling from left to right. If a smart but dishonest utility customer pulled his meter out of its electrical socket and put it back in the socket upside down, the meter would run backwards. Do this for, say, 2 weeks out of the month, and the customer's bill would be roughly 1/2 of what the bill should be based on his use of power. Remember that a utility is a business, and as such, it must be paid for the product it sells. Stealing electricity is a criminal offense, but more importantly, stealing it increases the cost of everyone's electricity. Why? Because roughly 4% of the power in the United States is stolen, and the utilities must make that lost income up by charging you and me for the other person's dishonesty. Here again is yet another reason why the utility companies want to make their meter systems more modern and secure to eliminate theft of power. When electricity passes through an electrical conductor like a wire, a weak electromagnetic field surrounds the wire in a donut-shaped ring. Because this magnetic field is closed in a ring-like geometry, it has no effect on its surroundings. The magnetic field cannot be detected perpendicular or straight on from the wire. The only way this weak electromagnetic field can be measured is to surround the current-carrying wire with another wire or many wires wound around an iron core to couple the magnetic field. The strength of the magnetic field is related to the current flowing through the wire. The higher the current, the greater the magnetic field. The strength of the magnetic field can be measured using a current coil and electronics for amplification and measurement. And in fact, that's exactly how this electrician's ammeter works. Let's use this ammeter as an example by measuring the current flowing through this meter in this test apparatus, which can generate up to 300 amperes impressed across a 240 volt input. By inserting the ammeter with the current probe, the circular probe surrounding the current conducting wire, I now show a current of roughly 20 amperes. And we look at the dial below this variable transformer, and it agrees, 20 amperes. I increase the current flowing through the wire, through the meter, 90 amperes, 100 amperes, 120 amperes, 150 amperes. I remove the current probe from the wire, and I show 0 amperes. I can move the ammeter close to the wire, far away from the wire. It has no effect on the display. The only time I register a reading is when I surround the wire and couple the toroidal or the donut-shaped magnetic field directly to the electronics inside this meter. This is exactly how an electronic power meter or smart meter works. It is time to go inside the smart meter, so to speak. What should we expect to see inside the meter? First, let's review our block diagram. The first thing that we see is a simple set of conductors. We can think of them as wires. These wires carry all of the electricity the homeowner or building uses. That is to say, the entire electric load of the building passes through these simple wires, or conductors located inside the meter. In a residential meter, there are typically two such conductors. We have power going into these conductors from the utility and their local distribution transformer, which is located on the neighborhood telephone power pole, or on a pad. The power goes into the meter through two terminals, and then the power goes out of the meter through two terminals and is routed through the fuse box or breaker panel to the inside of the building to devices such as light bulbs, appliances, television sets, computers, and other electronic equipment. A current sensing coil is placed around the conductors inside the meter, and this current sensing coil is conducted to a very sensitive set of electronics which amplifies the small analog signal coming out of the sensor coil produced by the magnetic field traveling through the current conducting wires. Remember that when we pass electricity through a conductor, it generates a small magnetic field in a circular pattern located around the wires. The analog signal is converted into digital data, which is then processed by the internal microprocessor and the calculator electronics, timed and controlled by a clock. In this case, we represent that with this cluster of 4 instruments: voltage, current, time, and mathematical calculation connected to the current sensing coil through the 2 blue wires. Accumulated watt-hour or kilowatt-hour readings are displayed on the meter's liquid crystal display. In this case, the display is located on the inside of the inner, what we call, meter clamshell. Data is sent to the utility company via the wide area network transceiver. Utilities typically own a wide area network which can consist of many different pieces, including public access communications. The wide area radio transceiver operates at the 902 to 920 megahertz frequency band and is similar to a cordless telephone in terms of its power output and its frequency. It is absolutely harmless to animal and plant life. The home area network transceiver operates at the 2.4 gigahertz frequency band using the Zigbee communication systems and protocol. This is similar to a hands-free cell phone ear unit, which operates at a similar frequency using Bluetooth, and which you wear on your head, literally in your ear, for hours at a time. It is also similar to home wireless security systems, wireless keyboards, your wireless mouse, and a myriad of in-home products like wireless game controllers, wireless television set cable box converters, wireless headsets and loudspeaker systems. And in fact, there are roughly 1 billion such devices located throughout our country. Now that we know what to expect based on our block diagram, let's take an actual look inside a Landis & Gyr focus meter. Firstly, we see the base of the meter. The base on its rear has 4 conductors, or what we call stabs. These conductors or stabs are basically connected to the internal wire or bus conductors, which in this case are about 3 inches in length on each side of the meter. We also have a current sensing coil. In this case, we see a black current sensing, what we call a current transformer, in a toroidal configuration. And the output of this current sensing coil is connected to the meter's electronics with these 2 wires. The meter electronics is located on this circuit board, and it operates using very low voltages, 12 volts and 5 volts, which is produced from a switch mode power supply. Switch mode power supplies are used by virtually every electronic device in your home connected to 120 volts. Things such as your iPhone power charger, television sets, electric clocks, all of these devices use switch mode power supplies. The electronics is connected to the liquid crystal display located inside the meter's clamshell using a series of electronic connecting points, or what we call pads, on the rear of the circuit board. And the interface communications, the wide area network and home area network, is located on a daughter circuit board connected to the same electronics which produces the meter calculations and stores that data. The typical interface communication module is built by a third party such as Silver Spring Networks as a prime example. Needless to say, there are no radioactive parts, and the smart meter does not emit any kind of radioactivity or nuclear radiation. None whatsoever. On the other hand, my government issue military wristwatch, which I've worn for about 15 years, does emit a very, very small amount of nuclear radiation. Why? Because it uses tritium, a form of hydrogen, to make the dial glow in the dark. And in fact, there's a radioactivity symbol on the dial of the watch indicating that it is a tritium dial watch. There are some misunderstandings and popular objections to the smart meter. And principally these are, 1, that they create magnetic fields. However, as can be seen, this meter creates no new magnetic field. It simply has 2 wires passing through the meter, and they create no new magnetic fields. The magnetic field surrounding these wires is no different than the magnetic field surrounding the wires going into the meter and coming out of the meter throughout the house or the building. A second objection is that they create radio frequency pollution. There is no such thing as radio frequency pollution. Low power radio waves are nothing more than the far effect of electromagnetism at a frequency set by the transceiver or transmitter. The power level of the smart meter transceiver is extremely low. And in fact, it's so low that one very big engineering challenge is getting the signal inside the house or building, because the meter is typically mounted in a metal box outdoors, which absorbs a great deal of the radio signal, and the building construction materials like brick, block, metal, etc. absorb most of the remaining signal. This reduces the signal almost to the point that it cannot be received inside the building. And remember, the field strength of radio frequency energy is inversely proportional to the square of the distance between the transmitter and the receiver. If you double the distance from the meter to a receiver, the signal level goes down by a factor of 4. The final objection, which is commonly spoken about, is the invasion of privacy. And again, this is absolutely untrue. The meter measures the total power load in the building or home. It measures the total sum of all operating loads, like all light bulbs, TV sets, computers, appliances, and the like. However, because all of these are connected in what we call a parallel circuit, the low-cost residential power meter cannot tell what loads are on and what devices are turned off. It can only tell the total amount of power being consumed by all the loads that are, in fact, turned on. The popular statements about the smart meter being used to spy on citizens is nothing more than an urban legend. It simply cannot be done based on a residential smart meter and its technology. There is an ongoing debate about just how frequently a smart meter needs to communicate with the utility by transmitting data. This relates to the concept of the new smart appliances and how they work. This also relates to the need for demand response and the limiting of peak demand, or the amount of energy used at instantaneous periods of time for very short instances. Whereas a utility company may have a meter programmed to send lots of data to the utility, say at a periodic frequency of every 10 to 15 minutes, most of the mathematical calculations for advanced rates such as time of use and demand rates can be performed inside the meter or in the building. Thus, the need for frequent communications can be eliminated. Since most of the new smart meters allow for the utility to remotely program the meter's operating system, the utility can change the data transmission schedules from, say, every 10 to 15 minutes to, say, twice a month. And in the latter instance, the amount of data can be limited to the minimum amount of data needed to produce a bill, as opposed to 15-minute time of use interval data bin dumps. Remember that most of the calculations can be performed inside the meter. Only its operating system needs to be changed to support this. The bottom line is that the smart meter is a safe, accurate, and friendly device, a friend of the homeowner. They ensure that runaway bills are a thing of the past. They ensure total precision and accuracy of billing. They eliminate the need for utility personnel to intrude on the property owner's property, except in rare emergencies. And the meter's information can be brought inside the home or building to allow better management of energy use and expenses through real-time energy feedback, thus conserving power, which is important from a societal standpoint until we solve energy, and it's important for consumers to better manage their money, to save money. Additionally, most new appliances sold in the United States will be communicating appliances, which means these appliances will work together to lower peak demand and save the customer additional money. Why? Because the price of power is a function of demand. The price of wholesale power is greatly affected by what we call demand versus critical peak demand. Remember, your utility company could care less about the way you spend your money and how you use your power. This new technology puts you in control. The utility company only cares about getting accurate energy usage information for billing and lowering the peak demand to the extent possible in times of potential blackouts and brownouts. Additionally, the utility's interests are served by eliminating theft of power and by additional functions and features of the new meter technology, such as remote service outage reporting. The vast majority of Americans are served by utilities who are either publicly listed, stock exchange-based companies or cooperatives where each customer is part owner. No utility is concerned with using their transmission, distribution, and smart meter systems as a law enforcement tools, like some popular anti-smart meter groups would have you to believe.